Did you guys notice anything? Notice a pattern when you factored all of these? Yes? What do you get for the first one?
X minus 2.
X plus 2?
Yeah.
This one is x plus 5, x minus 5.
Does it matter which plus or minus goes like first? Okay.
No. You could put x plus 2, x minus 2.
Okay.
Number 3 is x plus 9, x minus 9. Anyone get number 4?
2x minus 3, 2x plus 3.
2x minus 3, 2x plus 3. What are you noticing here? Anything?
They all have like what's it called? I don't know what it's called.
I don't know either. I don't know what you're trying to say.
Like how 4 is 2 times 2.
Oh, 4 is 2 times 2.
25 is 5 times 5.
25 is 5 times 5. X squared is x times x.
Yeah.
81 is 9 times 9. 9 is 3 times 3. Hey, 4 is 2 times 2, and 25 is 5 times 5. And then if you just go by the pattern, what do you think the last one's going to be?
10x and
10x and 10x. 1 positive, 1 negative, and 7 and 7. Here is your next kind of factoring. It's called the difference of two squares. I think that's the word you were looking for, Kennedy.
Yeah.
Squares. You know what square numbers are?
4, 25, 81, 9.
4. Okay, let's go through them. 1, 4,
9, 20,
16. I'm doing this to like square.
Oh, 25,
25,
36, 49, 64, 81, 100, like 121, 144, 150, no,
169.
Yeah, okay, yeah, that's what it is.
You want to keep going? 14?
No, I don't know, 14.
But yeah, those are all squared numbers, right? A number times itself. Whenever you have, look at, I just put these 0 x's in here because if I would have just wrote it like this, you would have put, I don't know how to factor those. But look at, notice they were all something squared minus something else squared. If I take out the 0 x's, something squared minus something else squared, something squared minus, they're all, notice that? This is, call it the difference of two squares. So anytime you have something squared, give me a square number.
36.
36 x squared minus, it has to be minus, it cannot be plus. Give me another number, square another number.
49.
49. You could factor that quickly and easily if you recognize what you're working with. You have to be able to recognize, oh hey, look it, that's a square number, that's a square number, and there's a minus in the middle. All you do is take the square root of that one. What's the square root of 36x squared? 6x. What's the square root of 49? 7. 1 positive, 1 negative, it'll always work out that way. Because these are the exact same factor, just with 1 positive, 1 positive and 1 negative. That just means, come on. Oh, like a sunflower seed skin. That just means the middle term is always going to go away. You'd have 36x squared if you multiplied it. Then you'd have minus 42x plus 42x. So that's 0 in the middle. That's always going to happen with these. Want to try a hard one?
No.
Let's do it. Yeah.
Okay, here's a hard one. This is about as hard as I can make it. And this will mess you up too, so feel that.
Yep.
There it is. Do you have something squared minus something else squared?
Yeah.
Yes, you do. I don't think there's any this crazy ones. Two sets of what's the square root of the first one?
3x.
3x. Put 3x and 3x. What's the square root of the second one?
2x.
2xy, 2xy, 1 positive, 1 negative, you're done. That's it. Last example. Try it real quick. Got it?
I think so.
You get?
Me?
Sure.
X to the second plus 9, x to the second minus 9.
Oh, so close. Why'd you go? No? You don't know? Anyone go further? You haven't had one yet that's factorable more than once, so I respect your answer. That's good. If you factor something and then you see one of your factors is still more factorable, you keep going. Do you see one that's still factorable here?
9.
This one is still factorable. This one is not. I should have explained why, but I haven't. That one is x plus 3, x minus 3. There is your final answer of a completed factor.
Why?
Yeah,
Why
you gotta
is?
explain that.
Yeah.
Yeah.
Why is?
Why is that not factorable?
Yeah.
What do you think it should be? Go ahead. Wait.
Oh, I guess it'd just be plus 3 plus 3, wouldn't it?
X plus 3, x plus 3?
Oh.
But guess what happens when you multiply that out? You get x squared plus 3x
Yeah.
plus 3x plus 9. So you have that
Okay,
plus
that makes
6x in the
sense.
middle. The middle term doesn't go away.
That makes sense.
If you think they're both negative,
So
still,
only
you
like.
get minus 6x in the middle.
So only the negative one is.
Only, it has to be, that's why it's called difference of two squares. Difference meaning the subtraction of two squared numbers. It has to be a minus sign. If that's a plus, it's not factorable.
But like you can only factor out more than minus 1.
Yeah. This is not factorable.
So if it's a plus, it's never factorable?
Yeah, for this. If you have two squared things and a plus sign in the middle, it's not factorable. If you have two squared things and a minus sign in the middle, it's factorable. It's this. That's why we say difference of two squares has to be the difference of the minus sign. Okay, moving on. This one sucks because you have to memorize something. Y'all like memorizing or else you wouldn't be here. Sum or difference of cubes. There is no sum of squares factoring. But there is sum and difference of cubes. Your book kind of touched on it when we were doing division. There was one problem I did really quick. But, basically, you have to memorize something. To factor x to the third plus y to the third, you go like this. It's always in this same format. It's x plus y times x squared minus xy plus y squared.
Well,
I will show you the easy way to memorize it in a second. If you have difference of cubes, it's x minus y times x squared plus xy plus y squared. to memorize?
No.
Here, look at. If I just break it down a little bit, it's easy to memorize. If you take the cubed root of each one, that goes here. Square that one, multiply them together, square that one. For the signs, this one's always the same, this one's always opposite, this one's always positive. My pre-calc is affectionately called this SOAP.
Same, opposite.
Same, opposite, always positive.
Oh.
They're like, how do you factor this one? And I just go SOAP, and they go, oh yeah, it's weird. Okay, that has nothing to do with it. It's just
Yeah, but that's like PEMDAS.
It's like PEMDAS, yeah, it's just some random thing that helps you go.
How do you spell opposite?
Opposite,
Or,
O-P-P-O-S-I-T, or SOHCAHTOA.
Yeah.
So,
Opposite.
here's an example of one of these. Let's go with something like x to the third minus 8. First thing you should do, take the cubed root of each one.
2.
So like the third root of x to the third is just
X.
x. The third root of 8 is
2.
2. So that's your first set of parentheses, x and 2. I always do signs last. Then I come over here to my long parenthesis, take this one, square it. So what's x squared? Squared. The middle one, multiply them together,
2.
2x. And then the back one, square this, 4. Then fill in your signs. Same, opposite, always positive. It's kind of just memorization on this one. The hardest part about this is recognizing the cube numbers. Can you list the cube numbers like you did the square numbers? What's
So
more?
that first parentheses, it's the same also?
What do you mean?
Like, I'm confused. I don't know. This, go.
What do you mean?
I don't know.
The signs? Are you talking about signs?
Yeah.
This first sign is always the same as whatever you're factoring.
Oh.
So if that was a plus, that one's a plus. Then the next one's always opposite from that one. And then that one's always positive in the back. Like I said, recognizing cubic numbers, sometimes challenging for people because you've never really thought of it.
So is the x squared always positive?
Yes. Like 1 is a cube number. 8 is the next one. What's the next one? 27. 3 cubed is 27. And then after that it's 64, 125. And if you know those first 5, you'll be good. Because after that they get big. It's like 216.
Yes.
And I don't even know. They get too big. So here, one more example, then we'll do our third and final factoring. Like, let's go 27 x to the third minus, or let's do a plus. Let's go like 64. And let's put a y in there. Let's make it to the 6th. First hardest part is recognizing that both of those are cube rootable. Making up words again. So you got to do the third root of each one. If you're like, how do I do that? You know how to do that, don't you? What's the third root of this? If you're like, I don't know, draw it, do it. Just go like this and be like, oh, hey, yeah, I remember we had a whole quiz and a test about that stuff, so I know how to do that. 3 times 9, 3 times 3. Hey, it's 3 x.
What if something is cube root and square root?
Oh, Charlie, you're a man of great vision. You'll see. One won't do one of those today.
Only one.
It gets ugly, let's just say you basically pick one to do first, and then you do the other one, like, and then whatever you do, it'll still be more factorable, and then you gotta keep factoring.
Fun.
We're not gonna do multiples today. Cube root of that, 64, y to the 6, let's see, it's 4, it's, cube root of 64, it ends up just being 4, y squared, right? You understand that part?
Oh, yeah.
Okay. So then put down your little parenthesis and then your big parenthesis. These just go right there. 3x and 4y squared. What do you think the first term of the big parenthesis is going to be, Gabriel? Andrew Ball?
3x.
Huh?
3x?
No. Go ahead, Karen. You must square this and put it here.
9x squared?
9x squared. You have to square the whole thing. That's what I was trying to get at. Square that whole thing, so it's 9x squared. Multiply those together, put it in the middle. What do you get when you multiply those together? 12xy squared. What do you get when you square that? 16.
Y to the fourth.
Y to the 4th. Then come through and fill in the signs.
Positive, negative, positive.
Same as that. So positive, opposite of that. Negative, always positive. And look down. What time? 11:08. Maybe we'll save grouping for tomorrow. I don't want to throw another kind of factor at you right now. Plus you have homework, so you gotta have some time to try to work. It's gonna be on F2.
Ow, my hair.
And I gotta change it a little bit now. Oh, no, I don't.
Can I have one? Fever?
No left column here, just 1 through 18, all of them. Sounds like a lot, but I expect you to bang them out pretty quick.
1 through 18. It's just left column,
Yeah, you feel like
no?
No, not today.
Oh, never mind.
It's 1 through 18, all.